We're going to use the quadratic formula to solve quadratic equations like the one written here, which have irrational solutions. Now, in order to use the quadratic formula circled here, we have to first make sure that our quadratic equation is written in standard form shown in the bottom left. Now, if I look at the red equation that I have, I notice that it's actually not in standard form because it's not set equal to 0. So that's going to be our first order of business. We're going to add 10 to both sides of this equation so that we can set it equal to 0. And on the left side, I'm adding it to the negative 13 because I can only add like terms, so I can only add a constant with a constant. So on the left side, I'm going to bring down that 2x squared minus 7x, negative 13 plus 10 is negative 3, equals 0 because negative 10 plus 10 cancels out, it equals 0. All right, now that I have it looking like the one down here that's in standard form, what that allows me to do is identify what A, B, and C are so that when I go to substitute them into this quadratic equation up here, I know which values to substitute. So let's look at our quadratic equation in blue and let's identify what A, B, and C are. So A is the coefficient of x squared. So in my equation, the A value is 2 because 2 is the number before x squared. B is the coefficient of the x term. So in my equation, that would be negative 7. And C is always the constant number, the value that's by itself without a variable. And so in my equation, that value is negative 3. Now that we've identified what all of our variables are, we can substitute into this formula. So I'm going to start to rewrite the formula. X equals, and I'm going to start to substitute the values into my formula. So I'm going to write negative, and then in parentheses, instead of writing B, I'm going to write the value of B, which was negative 7. If I keep going, I have plus or minus the square root of, again, just following up here in the formula, B squared comes next under that square root sign. So instead of writing B squared, I'm going to substitute B with the value that we have, which is again negative 7. So I'm going to write negative 7 squared, being careful to put that negative 7 in parentheses as I substitute it, minus 4 times A times C. So I'm going to replace A and C with their values. So A is 2 and C is negative 3. And all of that gets divided by 2 times A, but my A value is 2, so it's 2 times 2. All right, at this point, you can go ahead and throw everything in the calculator if you'd like. I'm going to continue to solve by hand so you can follow along. So we have negative 7, which is the same thing as negative 1 times negative 7, so we get 7 plus or minus the square root of negative 7 squared is 49. Negative 4 times 2 times negative 3 is going to give me a positive 24. And all that is divided by 4 because 2 times 2 is 4. All right, if I keep going, I get x equals 7 plus or minus the square root of 73 all over 4. Now, when I get to this point, I notice that the number that's inside the square root, 73, is irrational. It's not a perfect square. I'm sorry, it's not a perfect square, so the value of its square root is going to be irrational. So at this point, I could stop and just write my solution like that and I'd be correct. The other way to write it is to split this up so that it's a little more obvious what my two solutions are. So we can write this as x equals 7 plus the square root of 73 divided by 4, and x equals 7 minus the square root of 73 all divided by 4. So this in the rectangle is another way to write the solution of this quadratic, all right? Now, if you want to have a better idea of what the approximate values are here, you can throw this all into a calculator so that we can see where this parabola is going to hit the x-axis, where are its roots. So if I estimate the values, it's going to be about 3.8 and about negative 0.4, so that if I graph this parabola, I'll notice that those are the two values approximately at which this parabola will hit the x-axis. All right, so that is how you use the quadratic formula to solve quadratic equations with irrational solutions.